So we're going to be doing the solution for the chapter 3 test, form A. Recall that this is a form A. So I'm just going to write here form A. So you remember that that's form A that we're going to look at. So the first question what they're asking us in this form is say, for what mathematician is the famous triangle theorem named? Well, recall that in chapter 3 we're working about right triangles, and whenever you have a right triangle, we're talking about this very, very important theorem, which look like this: a squared plus b squared equals to c in any right triangle, right? In any right triangle. So, but who was this mathematician that came out with this number, so with this theorem? So for what mathematician is the famous triangle theorem name is Pythagoras. Actually, he's also known as the father of numbers. Okay, the father of numbers is going to be Pythagoras. Pythagoras. So Pythagoras. Now that was for part A. Part B, they're asking us in what city was he born. We know that Pythagoras was born in the city in the Greek island of Samos. So the answer there should be Samos. Letter C. In what city was his brotherhood based? Well, after Samos, he moved out to the city of Croton, also known as Magna Graecia. Okay, Magna Graecia, which Magna Graecia is actually it's a Latin word for Great Greece. So if you Great Greece, okay, so this should be Magna Graecia. Okay, so actually it's Great Greece. So that will be for the first question. What was the mathematician name? Is Pythagoras. In what city was he born? In the Greek island of Samos, and then he moved out to Croton at Magna Graecia, which actually means Great Greece. Okay, so let's go move on to the next following question. Number 2. Well, in this particular, they say find the perimeter P and the area A of each figure. So in problem number 2, they want you to find the perimeter and the area of this isosceles triangle. Whenever you have an isosceles triangle, remember that if this is a 90-degree here, well, this should be 45, 45, right? The only right isosceles right triangle is the 45, 45. And also we know that the 45, 45, well, the opposite should be the same. So these two sides are equivalent. They are the same. They are congruent. So if the sides are congruent, we also call this one L and L, right? So we're going to have those L's there. Let's go back to the problem here. And how am I going to find the L? Recall that the hypotenuse, the one that opposes the 90 degree, is 12 meters. So I'm just going to write 12. Remember that your units are meters. So how am I going to find the length? Well, the leg there, L is equals to, there's a relation between those two. Actually, the hypotenuse is equal to leg times root 2, or we can say that the leg is equals to hypotenuse over root 2. Well, we're looking for the leg, so I believe we must use this one here. So using that one, leg should be equals to 12 over root 2. But recall that every single answer must be rationalized. So I'm going to rationalize this times root 2 top and bottom. Look what we're going to get. So we're going to have 12 root 2 over root 2 times root 2 is 2. And if I simplify this part here, I'm actually going to get 6 root 2. So my leg should be 6 root 2 meters. So we pretty much have our triangle here. So we're going to have our triangle which has like 12. So I'm going to kind of draw it here. So we're going to have this triangle who has going to 6 root 2 meters. And here it's going to have another 6 root 2 meters. And this one is a 12 meters. if I'm looking for the perimeter, recall that the perimeter is the sum of every side. So perimeter should be equals to 6 root 2 plus another 6 root 2 plus 12. So after that, we're going to add them, combine like terms. So I'm going to have 12 root 2 plus 12. But because perimeter is the distance around it, so it should be 12 root 2 plus 12, all of these with the units of meters. So that should be your first answer that you're going to be writing in here. So if I were to put my answer here, I'll put P equal to parentheses 12 root 2 plus 12 meters. So, but the problem is not done there, because you want to find the area as well. So let's do the find the area. And to find the area of any right triangle, we must use the product of the legs. So I'm going to write A equals to 1/2 base times height, right? Or it could be the product of the legs. So because the base in this case is going to be this one here, and then the height could be this, or vice versa, right? This is the base and this is the height, or just the product of the legs. So you're going to have 1/2 times 6 root 2 times another 6 root 2. So A equals to, well, I'm going to do some math here. I think I reduce this. It's going to be 3 root 2. But this 3 and this 6 will actually make 18. And the root 2 times root 2 is actually 2. So therefore, the area should be 36. But 36 what? Is square meters, or meters square. So my answer, what I have to write for number 2 here, area is equal to 36 square meters. So that should be your answer. Let's move on to the next following problem. Problem number 3, we have to find the angles first, because they say it's a right triangle. But well, to find the other sides, as we've been covering in class and all of these chapters, it's about using those special triangles. So if that's 30, what will be the measurement on this side here? Recall that every triangle must add up to 180. Therefore, the measurement here should be 60. Why? Because 30 plus 60 is 90, plus another 90 becomes 180. So I know I'm going to have a special triangle there. And also recall that whenever you have the 30, 60, 90 triangle, the 30, 60, 90 right triangle, we're going to use this special relation between the length, the long side, the short side, and the hypotenuse. Let's recall a few of them. The hypotenuse is usually, or is always, twice the short side, or the long side is equals to the short side times root 3. Okay, and then the other one you can derive from it, but this is the two most important ones that you need to know. Now, what am I given here? I'm given that the short side, the one that opposes the 30, is actually 12. So I'm going to rewrite my triangle here, just so I have this nicely. So 90 degrees here, this is 12. This is the short side, okay? And now the 30 degree opposes the shortest side, definitely. This is a 60 here. And the 60 should oppose the long side, and this, the one that opposes 90 degrees, is the hypotenuse. So how am I going to find the next side? Well, I know the short side, therefore hypotenuse, I know this one here, right? So hypotenuse should be equals to twice the short side, which is 12. Then hypotenuse is equals to 24. So there's no units in here. Just be aware that you're just gonna have units. So then so we found the hypotenuse. Now let's find, this is actually equals to 24. And let's find the length, the long side, right? The leg of the long side. So, well, I have S once again. So L is equals to 12 times root 3, which actually is going to be 12 root 3. So this leg here should be equals to 12 root 3. Okay, so now I have all the sides. So I have enough tools, or I have enough information, enough data to find the perimeter. So the perimeter of any figure is usually the sum, or it is the sum of every side. So in this part, I'm gonna add this one up plus this here. So the long side plus the short side plus the hypotenuse. So I'll have a 12 root 3 plus 12 plus 24. Now, if I have that, then my perimeter combined in like terms, I will get, well, 12 plus 24 add up to 36, and I cannot combine this one, so it's just 12 root 3. And what type of units do I have? Well, since my units is not declared there, I'm just gonna have to write here units. Now, let's go for the area. Recall that the area is usually of any triangle is base times height. But in this case, the base and the height are gonna be the legs. So it's gonna be area equals to 1/2 times, I'm gonna use one of them, the product of the legs, right? So it's gonna be 12 root 3 times 12. Now I'm gonna use algebra. I'm gonna have to reduce here. 2 goes into here once, 2 goes into here 6 times. And 6 times the 12 in here is going to give me 72. Yes, that should be a 72. 72 root 3. But what type of units? Square units. You can write a square units like this, or you can just write units within a square here. Okay, so either of these two answers will be valid. All right, but make sure you remember that if the unit is not stated, you still want to write units. So perimeter, whatever units there is. If you're finding area, you have square units. So that should be your answer for number 3. So in your answer sheet, you will have to put here P equal to parentheses 36 plus 12 root 3 units. And for the area, you're gonna have to write 72 root 3 units being a square, or square units. Okay, so that's for problem number 3. Let's keep moving to the next following problem. So now they want us to find the perimeter and the area of this quadrilateral. Well, to find this quadrilateral here, to find the area and the perimeter, to find the perimeter, we need to know all the sides. I have the 13, I have the 3, and I don't have this part here, over here, but I do have the 12. So how am I gonna find this? It's gonna be a little bit challenging. I'm gonna redo my picture here. Look at this triangle here that you have. You have a right triangle. You at least know these two sides. If you know these two sides here, we can definitely find the third one here. How can we find that one? By using Pythagorean Theorem. How is my Pythagorean Theorem? What do I need to do in here? Well, what we have to do is to use a squared plus b squared. A squared plus b squared equals to c squared, which means that every leg being a square, right, is the square of the first leg plus the square of the second leg equals the third leg. Arbitrarily, let's call this an x. Okay, I'll call this an x. If this one is an x, I will have, well, 12 squared plus x squared equals to 13 squared. And what is 12 squared? And if we do that in our calculator, you're gonna have 144 plus x squared equals to 169. Now subtract 144 each side, and later you will get x squared equals to 25. Now you apply the square root each side, so you're gonna get x equals to plus or minus a square root of 25, which actually is plus or minus 5. But because x is the length of something, this should be just 5, positive 5. We don't take negative here. Okay, so that's how we're gonna find that side. Now, in the other side, on the other part of this quadrilateral, I have this figure, right? I have this part here that looks like this, where this is 3 and this is 5. And I will apply the same technique because this is a right triangle. So let's call this a y. So what are we going to have is that 3 squared, around here, 3 squared plus y squared equals to 5 squared. Now 3 squared is 9, plus y squared equals to 25. Subtract 9 each side, you will get y squared equals to 16. Therefore, y equals to plus or minus root of 16. Therefore, y equals to plus or minus 4. But because we're dealing with sides, this should be 4. So later on, I have all my sides. Let's see. Let's identify. So if I match all of these together, my figure here should be looking something like this. All right. Something like this. I have my this side here, and this side here, which this is 3, this is gonna be the 4 that we found, and this is gonna be 12, and this is gonna be 13. Now if I'm looking at the perimeter, you're only looking at the quadrilateral, so the outside is 13, 3, 4, and 12. So the perimeter P should be equals to 13 plus 3 plus 4 plus 12. Either you use your calculator and add everything, or you do it by hand. 13 plus 3 plus 4 is actually 20, plus the 12 in here, you're going to have 32. So perimeter is equal to 32. So I'm going to have to write here 32. 32 what? Units. Because the units are not shown, so we just declare that these are units. Okay, so I might want to write here bracket units as a reminder. Now we found the perimeter, we got this one here. Now let's find the area. But how am I going to find the area of this quadrilateral? This is not a rectangle, this is not a trapezoid, it's not one of our common quadrilaterals. So but because this is breakdown in 2 pieces, I can either do this one here. So let me show you. I'm going to use the area of this triangle here, the one here, with the area of this triangle here. I'm going to dot it here, of this triangle here. So I'm going to have 2 areas. So I'm going to rewrite it now. So I'm going to have this triangle here. The area, the total area is, well, this is a 12, and this is a 5. And this is a 13, plus the area of this triangle here, which is 3, 4, and 5 as a hypotenuse. So let's find the area of each of them. Okay, so the total area, the big A, is going to be this area here, the area in here, plus the area inside here, this region. So the area of any right triangle is 1/2 the product of its legs, or base times height. So I'm going to have 1/2 12 times 5 plus 1/2. Well, be careful here, the legs are 4 and 3, so it should be 4 comma 3. Either you use your calculator to do this, or you do it by hand. 2 goes into here once, 2 goes into here 6 times. 6 times 5 is 30, plus, well, here goes twice, so I'm going to have plus 2 times 3 is 6. So my area A is equals to 30 plus 6, which is 36 square units. So whenever you fill out your answer, you're going to have to do P equal to 32 units. Well, not here, definitely. So it should be problem number 4. P equals to 32 units. And area equals to 36 square units. Okay, so that's for problem number 4. In problem number 5, they're asking us to find the perimeter and the area of this regular hexagon. So the key word here is the word hexagon. Well, actually regular hexagon. So whenever I have a polygon, if it's in regular hexagon, means that this n equals to 6 sides, right? We have 6 sides there, which means all the sides are going to be the same, and as well as the angles, the interior angles are going to be the same. So in this particular, I'm going to try to redraw my hexagon here. I know it's not gonna look perfect, but remember what geometry is, right? So all of these are gonna be the same, right? So each of them are gonna be 10, 10, 10, 10, 10, 10. Oh, we can easily find a perimeter then. If each of them is 10, then my perimeter is going to be 10 times 6 size, 10 times 6, which is going to be 60. But these were feet, right? So each of them is 10 feet. So I'm going to probably write here feet. So it's going to be 16 feet. Okay, so that's my perimeter. Now, how am I going to find the area? Well, the area is going to be a little bit hard because remember that whenever you have a regular polygon, you want to find the apothem, which is the distance from the center of it to one side, which is going to be perpendicular degree here. So we're looking for this part here, which is 90 degrees. It's called A. So I'm actually going to break these. I'm going to make triangle here. So that's the technique here, doing the triangle. But we're going to have to know what each side is. Well, if it's a regular hexagon, each of the sides should be 120, right? Because it's a regular hexagon. So if this part here, I'm gonna try to zoom this part here so you guys can have a better look of this. So I'm gonna zoom this part here in. So I'm gonna pretend that's a nice triangle there. So I have my 90 degrees here, and I have 10 here. And because all of these up to here, look at here, up to here, like from here to here was 120. And if I'm actually doing this part here, I should have this little part here should be 60 degrees. So if this is 60 degrees, then this is 30 degrees. Right? And then, well, if this is 90 here, this should be 90 in here as well. So by having that, we're saying that we have actually a right triangle of 30, 60, 90, which is going to follow into those like the 30, 60 special triangle, 30, 60, 90 special triangle. So, but what about this 10? What is this side going to be? Recall that because this is being bisector and like this side is equal to here as well, right? So this part here is actually half of it, so it should be 5, and this part is 5. So I really want you to focus on the left side of this triangle. I'm gonna zoom it in. Look what we're gonna get here. We're gonna get this part here at 90 degrees. This is a 5. This is a 60 degrees, and this will be a 30 degree, right? Now we have one side. We're able to find the other sides. Recall that the hypotenuse is equals to twice the short side, and also that the long side is equals to the short side times √3. What we're actually looking for, A, because to find the area of a regular polygon, recall that the area is equals to 1/2 the perimeter times the apothem, 1/2 PA. So, well, the perimeter from the previous question, we have it. From the previous question, to find the perimeter, we have this. So this one is like check mark, but the A, we didn't have it. So that's why we're doing all of this work. We really need to know the A to be able to find the area. So the A actually is the long side of this part here. So L, which is the apothem, equals to S, which S is 5, because it's here the short side, right? This was this S. So we're going to have 5√3. Therefore, my apothem should be 5√3. Overall, so now I have enough things. So I have P and now I have A. I can find each of these. I can find the whole area here. So area should be equal to 1/2 times the perimeter, which is 60, times the apothem, which is 5√3. So I'm going to do some math here. So 2 goes into here once, 2 goes into here 30 times. Therefore, my area should be 150 square root of 3. But recall that areas should have a unit. So what is the units in this case? A square feet, or I can just put feet to the second power. So on my answer here on the answer line, because they're asking us to put the answer in this space provided, my perimeter is 60 feet. Be careful with your units, okay? And the area is 150 square root 3 square feet, okay? If they're asking you for the exact solution, then you give 150 square root of 3. If they're asking you for the approximate solution, then you have to use your calculator. And what would you plug in your calculator? You could plug 150 square root 3. So let me use my calculator. 150 square root 3. That gives us approximately, let's see, this is approximately what? And I'm going to round to 2 decimal places. 259.81 square feet. So yes, that's in case if they're asking you for the approximate solution, but all the time we try to use only the exact solution. Let's find the perimeter and the area of this pentagon from Heck. So I'm gonna try to redo this part here. I'm gonna try to graph it again. So I have this part here, and I have something like this, and I have something looking like this, and assume this is 90 degrees. So, and I have a 45 degree here, and I have a 60 degree here. Now, and I'm giving this side that is a root 3 or a root 2, and this 4 root 3, and then I'm not giving anything else more than just the length of all of these, which is 7 root 3. Well, recall that to find the perimeter of this figure, I need to know all the 5 sides. 1, 2, 3, 4, 5. Well, I do not know this part here, and I don't know this part here either. So how are we going to look for them? Well, maybe I can do this part here. Look, you're just going to cut it from here. Make sure you trace a perpendicular line, which is a 90 degrees, right? So a parallel line from this one. So this will kind of be a rectangle with 2 triangles on top. So, and maybe I will be able to find this side here and the side here, and same technique with the 60 here. Probably we will be able to do that. So let's do that on the side. I'm gonna zoom in and I'm gonna look what is really happening in this triangle here. So I'm gonna zoom in that one. So that triangle should have something like this. You know, assuming it's 90 degrees, okay? And this is straight. So I'm gonna have an a root 2 here, and this is a 45, right? And if that's a 45, this should be a 45 as well. And same technique here. Well, first let me finish with this part here. So if this is 45, recall that the 45, 90 a special triangle has this particular property, which the hypotenuse is equal to the length times root 2, correct? Or you can say that the length is equals to the hypotenuse over root 2. So L, what I'm looking for, is going to be h, which is hypotenuse a root 2 over 2. Oh, gladly, this will cancel out and you're just left with 8. Also, that means that this side here is 8 and this side here is 8. 8 is up to here only, okay? So from here through here. So I found those sides. I'm almost there. I need to find these other 2 sides for the 60 triangle. So I'm going to probably just try to put it in here. Let's see. So this is going to be 60 degrees. And this part is given 4 root 3. And I'm looking for this short and length side, right? And we're having the 30, 60, and 90 right triangle, where the hypotenuse is equals to s root 3. It's actually hypotenuse twice the short side. And we also know that the length is equals to, the long side is equals to s, the short side, times root 3. And from there you can vary, change that, or you can say the short side is equals to the length times root over root 3. Well, I believe I only have the hypotenuse, so I might work with this guy here. So h is actually 4 root 3, right, equal to 2s. Well, if I divide each side by 2, I will get 2 root 3 equals to s. Also, I have the short side now. The short side is going to be here, which is 2 root 3. And then the long side, so if I use this, so L equals to S, which is pretty much what we just found, 2 root 3. Okay, so that should be, hold on, let me fix this part here. That should be 2 root 3 times root 3, right? Because that's S goes here. So L is equals to 2 times root 3 times root 3 is actually 3. So the long side, L is equals to 6. So that part should be 6. So what I'm going to do is now I'm going to kind of write it in here. So this should be, this part here, opposite, should be 2 root 3. Just from here to here. And this part here is going to be 6. Alright, so we have that part here. Now look, if this part here is 8 and this is 6, then everything here should be 14. Okay, and the same technique here. If this is 2 root 3, this part should be what? 5 root 3 to make the 7 root 3. And if this is 5 root 3, because it's a rectangle, this part is 5 root 3. Now I have every single side of the outer side, right, of the perimeter of this pentagon. So my perimeter, I'm going to probably sneak something here because I need a space for my area. I'll probably write here, like, my perimeter is the sum of everything of 5 root 3 plus 8, right, plus, what else do I need to write here, plus a root 2, plus 4 root 3. I'm probably going to align it here. Plus 4 root 3 plus 7 root 3, right? 7 root 3. I'm probably going to align it here. Just doing some math here, some weird math, but yeah. And then plus 14. So if I add everything up, I will get, well, between the like radicals, I will actually have 5 plus 4 plus 4 is going to be 13 root 3 plus 22 plus 8 root 2. So that should be your perimeter. P equals to that, and with units. Okay, don't forget about put all of these and write just units. So that's how we're going to find the perimeter. So that was a really long problem because we had to find every single side by using a special triangle, and now we're going to find the area. Actually, I need to do the area between 3 things. So my area is going to be the area of 3 things of this top triangle here, the one that I have the 8 by 8, right? 8 root 3, plus this other triangle here that I had 6 2 root 3. We don't really need the hypotenuse for this particular problem, but I'm just going to write it there. Plus this rectangle here, which is a 14 by 4 root 3. 14 by, 5 root 3. Now I'm going to find the area of each of them. This is a rectangle, okay? So I'm going to put 90 degrees here. So you know this is a rectangle. So the area of the first triangle here is 1/2 the product of the legs. So I'm going to do 1/2. So 1 over 2, 8 times 8. 8 times 8. Plus 1/2, 6 times 2 root 3. Plus the product base times height is 14 times 5 root 3. So this problem got pretty long. So make sure you're able to do all of these step by step. So here I'm gonna try to cancel out something. It goes into here 1, goes into here 4 times. 4 times 8 is 32, plus this will simplify. 3 times 2 is 6, 6 root 3. Now this is going to be probably calculator, but 14 times 5 is 70, so it will be 70 root 3. Now I'm going to combine like terms here. I believe these are like radicals. So, but I still have my 32 plus 76 root 3. Now, because this is an area, this was the area of these pentagons from Heck, well, and we say that all of this is in units, it's not given, so this should be square units. So you can either write square units or put unit with a power of 2. So square units. So yes, that was all the work for this particular problem. Let's review this. First, you needed to find all the sides by using this 45, 45, 90, 90 triangle. And then you will do the same thing with the 30, 60 right triangle. So we found every single side, and recall that the measure from here all the way here was the 8 plus 5 root 3, because you're adding these two sides here. Then you do the 8 root 2, and then you do the 4 root 3, and then you do the everything, which is 7 root 3 and the 14. Recall this was a pentagon, so you're only supposed to have 5 sides. So 1, 2, 3, 4, 5. Okay, so you add all of them up here, and you have your perimeter here. Okay, then to find the area, we split into 3 pieces of one right triangle here, which is 8 by 8, right? And 8 root 3 as your hypotenuse. But recall that the area of a right triangle is pretty much 1/2 times the product of the leg. 8 times 8. Same technique here. 1/2, 6 times 2 root 3. And well, of this rectangle, which is just base times height. And you solve this algebraically. You do your math here. 2 goes into 8 4 times. 4 times 8 is 32. Same technique here. You reduce that. 2 goes into 6 3 times. Times the 2 root 3 actually give you 6 root 3. And this 14 times 5 root 3 give you 70 root 3. Combined in like terms, you will get 32 plus 76 root 3 square units. So all of this is for the problem number 6. Let's move on to the next following problem. In this word problem here, we have that an 8-foot statue is standing 54 feet from a lamppost that is 44 feet tall. Use similar triangles to find the statue's shadow's length. Okay, well, let's visualize this, because in any word problem, you always want to visualize. So let's say here's the statue. I'm just gonna do the statue. Okay, this is gonna be someone's statues. Okay, just gonna do there. And then you have a lamppost here. I probably should use yellow for this, but this is your lamp. Okay, I'm just gonna use that, like it's very bright. And then you go from here to here. Well, remember that for them to be standing, that should be like a 90 degree each of them, right? And they say that this one here reflects a shadow, right? Which the shadow is going to be somewhere in the bottom part here. Okay, this is going to be your shadow. This is your 44 feet tall, right? The lamp post. So I'm going to probably write here, this is my lamp post. Okay, and this is my statue, just so we know what are we talking about in this particular problem. This is a 44, and the statue is it stands 54 feet, so it's an 8-foot statue. So 8 should be here, and from here through here should be 54. They say find the shadow, like find this part X. All right, so that's my diagram there, but I'm gonna do it neatly again. I'm gonna try to do it nicely. So I'm gonna have a right triangle, something like this, with a 8 in here, which is 90 degrees here, 54, and this is an X, and this is a 44. So that's as neat as I could have. And we're all talking about feet. So I'm probably going to write here feet, just as a reminder that everything is in feet. So let's do algebra to do this part here. Now, because this is a 90 degree and 90 degree, you can talk about parallel triangles, parallel lines here. But usually what we actually have here is that this angle here is the angle that they share in common. So we're going to have a similar triangle. We're going to have this triangle here because it's angle, angle, right? So your similar triangle, because this one here and the one in here are the same. So we're going to have angle, 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 angle. So we have a similar triangle. So I'm going to probably separate them. Look at the small one. The small one is here. This is 90 degrees. This is X. And this is 8. Okay. And then I have this filling angle here. Okay. With the one that has 2 marks in here. And I'm also going to have the bigger triangle, which I actually happen to have a 44 in here, my 90 degrees in here, and then this is the tricky part. Be careful, it's actually X plus 54. Okay, so this one here is the one that they share, right? And this one here is the other angle there. So now, because these triangles are similar, so what I'm going to do is that I'm going to use proportions to solve this, to solve it algebraically. So I'm going to do a small to big. All right, so I'm going to put a small triangle is to big triangle. Okay, so this is going to be like my ratio. So I'm going to start with the corresponding size, right? The corresponding parts. So to this angle here opposes 8. As in the big triangle, that given side there opposes 44. Equal to, in here, the 2 marks opposes the X in the small one. Equal, in the 2 mark here, opposes the X plus 54. So I can solve this algebraically by cross multiplying. Now, if you solve this part here and you do a little bit extra of algebra, look what could happen here. You could reduce this. I'm going to use a different color, maybe just blue. 4 goes into here twice, and 4 goes into here 11. So pretty much my fraction can get reduced to 2 over 11 equals to X over X plus 54. And I do the math here, cross multiply each of them, right? Equals to 11x. I'm going to distribute, so it's going to be 2x plus 54 times 2. Either you use your calculator or do it on the side. It's going to be 108 equals to 11x. Now I'm going to subtract 2x each side, right? Algebraically part. So minus 2x minus 2x. What are we going to get? We're going to get actually 108 equals to 9x. If you divide each side by 9, we're actually getting, therefore, I'm going to put here, therefore, x is equals to 12. And what was x? We say the x, probably forgot to write here, x was the length of the shadow, right? The length of the shadow, of the statue. So I forgot to declare my variable there. Okay, so that's what we needed to do. So, well, in feet, right? So therefore my final answer is, what is the length of the statue? Is 12 feet. So it should be 12 feet. That should be your final answer. So if you were to put your answer in your paper, you're probably gonna write here just 12 feet. And always remember about your unit. So it should be 12 feet. Okay, so let's keep moving on to the next problem, which is problem number 8. Problem number 8. say the hypotenuse of a right triangle is 1 foot shorter than twice a leg, and the other leg is 1 foot longer than the first leg. Wow. So it's our problem, which they are not giving you any dimension because say find each side of a triangle algebraically. So we have to use algebra for this. Now, first thing is I'm gonna say, okay, I'm gonna have a right triangle. I might wanna, like have my visual idea of my right triangle. I'm gonna make this right triangle a little bit nicer. Okay, so there we go. That's my artistic skills. Okay, so 90 degrees there. Now, but I'm gonna start listing. I'm gonna do first leg. I'm gonna have two legs, right? First leg, second leg, and then I'm gonna have my hypotenuse, right? Hypotenuse. All right, or h. We can just write there h. You don't have to write the whole thing because h is gonna start for hypotenuse, or you can just hyp. You're just gonna get that's your hypotenuse. All right, so the first leg. Well, recall we want to be listing stuff, and you always let your variable the one that you know the least information about. Well, we don't know anything about the hypotenuse, but so far you can leave that of a little bit. Well, we actually do know. Say the hypotenuse is of a right triangle is 1 foot shorter than the twice a leg, and the other leg is 1 foot shorter than the first leg. Wow. So this problem should say here. So let me call the first leg x. All right, and they say that one is gonna be, then the hypotenuse is 1 foot shorter than twice the leg. So 1 foot shorter, 1 minus 2x. We were assuming about the first leg. Now the second one says the other leg, the second one, is 1 foot longer than the first leg. So it would be x plus 1, right? 1 foot longer than the first leg. Okay, so whenever they say, for example, the hypotenuse of a right triangle is 1 foot shorter than twice a leg, we were assuming that leg was the first one. Okay, so now I'm gonna write this on my triangle. So let's just arbitrarily say this is the x and this is the x plus 1, and this is gonna be 2x minus 1. So I'm gonna use this algebra. So how am I gonna do this with algebra? Recall that whenever you have a right triangle and you wanna know the size, we pretty much use Pythagorean theorem if we don't have the angles, because we don't have the angles in here. So we must use Pythagorean, which says a squared plus b squared equals to c squared, right? The Pythagorean theorem. So it means like every leg squared, so x squared plus x plus 1 squared equal to, let's say this hypotenuse 2x minus 1 squared. Now I'm gonna have x squared plus, I'm gonna FOIL this. Be careful, this is one of the common mistakes. We are tempted to say that a plus b squared is equal to a squared plus b squared. This is completely false. Okay, recall that if you have a plus b squared, that's actually a plus b times a plus b. So you have to kind of FOIL that thing out. Okay, so, or if you actually happen to FOIL and you have taken your math 60, and recall that this will be the first one square plus twice the product plus the second one square. So you can also apply that, and that's what I'm going to use it here. Or on the side you could have done your x plus 1 times x plus 1, okay, and distribute that. After you finish that, you will get x squared plus twice the product plus the second one square. So that's what you're gonna get. For this one, you will do the same thing. You either FOIL that 2x minus 1 times 2x minus 1 to give you the answer. After you finish that, you will actually get 4x squared minus twice the product, so 4x plus 1. Now this looks like it's gonna turn out to be a quadratic equation, but let me combine like terms before I start moving out. So 2x and an x squared is gonna be 2x squared plus 2x plus 1 equal to 4x squared minus 4x plus 1. Well, it's time for me to move everything, so I might want to move this side, this one here, to the other, so minus 2x squared each side, and I will do everything at once. You don't have to, but let's accelerate the process here. Minus 1, and then you will get, let's see what we're gonna get after that. After that, we're probably gonna get, well, 0 on one side. That was our goal. This is gonna be a 2x squared minus 6x. Well, these cancel. Oh, well, gladly I don't have to do any trinomial here. I just get to factor this part here. 0 equals to, well, greatest common factor is 2x, and I'm left with an x minus 3. Now, if this product is equal to 0, then that means that 2 equals to 0, which is impossible, or x equals to 0, or x minus 3 equals to 0. So I'm going to write that down. So x equals 0, or x minus 3 equals to 0. So that's what's happening with the 2. Be careful. I'm saying that 2, the product of all of these equals to 0. So either the 2 is 0, but the 2 can never be 0. So there's no way I'm going to do that. Or the x is equals to 0, or the x minus 3 is equals to 0. Well, in this part here, the x equals to 0 is one possible answer. These are my possible answers, right? For just the variable x, not for the actual dimensions of the triangle. That's my possible answer for x. Same technique here. Plus 3, x equals to 3 as my possible answer. So I'm going to keep writing here possible answer. But now we have to find the dimension of each side. So if I were to do, let's say, for x equals to, so after I'm done here, we'll go here. So for x equals to 0, my dimensions will be what? Let's say the first leg will be 0, and the other will be -1 and +1. But wait a minute. We're talking about geometry. I cannot have a triangle with side 0, neither with negative. So x equals to 0 is not going to be 1 over our possible answer. So x minus 0, this one is not going to be a solution, not a solution, okay? Maybe the x equals to 3. Let's find that out. For x equals to 3, what I'm going to have for my dimensions. Let's see. So I'll have short leg is 3. This will be 2 times 3 is 6, minus 1 is 5, and this part should be x plus 1 is going to be 3 plus 1, which is 4, right? So I might just look, x equals to 3. This is 3 plus 1 is 4, and then this is 2 times 3 minus 1. This is actually 5. So that's what my dimensions are going to be. And we're talking about what? Feet, right? So all of this is going to be in feet. So probably should have wrote feet here. So if you were to write your answer overall, they're asking you find each side of the algebraically. You probably will have to write here first leg is going to be 3. The second leg is going to be 4 feet, and then the hypotenuse is going to be 5 feet. Okay, so that will be your dimensions for this particular problem. So we have to involve a little bit of algebra here, quadratic equations, so make sure you review that. Let's move on to the next following problem. Okay, last problem. So a cat has fallen off a cliff in the diagram below. So right here, there's the cat is going to be somewhere here. Okay, so here's probably going to be the cat. Okay, I'm not very good at drawing, so that's probably my cat there. He's gonna fall all the way here. All right, so the cat can only survive 9-meter fall. So if this altitude here, this part here is more than 9 meters, then the cat will die. All right, so find the exact altitude. The exact means like exactly, you don't want to approximate it, of the cliff from the ground. if the cat is alive or dead. Is the cat alive or dead? Well, we will find out. So we need to first find out the altitude, if it's going to be more or than 9 or less than 9. So how are we going to do this? Say hint decompose into right triangles. All right, so it's going to be a little bit challenging. Let's see what we can do here. So in this part, I'm going to kind of draw my diagram again here to have a kind of better looking picture here. So it's something like this, and imagine this is all neat and nicely. Okay, so and my cat is somewhere here. My altitude should be 90 degrees from here, right? So my altitude will be 90 degrees here. All right, so we're trying to look for that. I'll call it X. All right, or just let's just leave there for a minute. I know that this is phi, this is 90 as well, and this is phi, and this is phi. Oh, wait a minute. If this is phi and this is phi, and if I have a 90-degree angle here, that means if I trace something here, like if I do from this diagonal to the ending point here, I'm going to have an isosceles right triangle who has what angles? 45, 45. So this part here should be 45 and this should be 45. But in the given problem, they told me that all of this here, all of this angle is 105. So pretty much 105 minus 45 is going to be 60. Oh, so it means that this angle here, look, this angle here, right here, this one is going to be 60 degrees. I'm just going to put, all right. Now, the same technique goes here, because if this is 45 and all of this was 135, then that means that this part here is going to be 90 degrees, because 90 plus 45 should be 135. Oh, so if this part is 60, 90, then this part should be 30 degrees. Oh, so everything starts to look nice now, because I'm decompose this into two right triangles. I could even have one extra right triangle here because I have a 90 degree, and if this is 45, 90, this should be 45, and if this is 45, this angle here is 45. So I pretty much have three right triangles. Let's find it out. How am I gonna get through this part here? So if this is X, this should be X, right? This is the two unknowns here. So let's first find this hypotenuse of this 45, 45 triangle. So I'm gonna just rewrite that thing here. So I'm gonna have phi. This is 45. This was 90 actually. This is 90, and this is 45. So let's just write this a little bit nicer, because whenever you're doing geometry, you want your graphics to be as accurate as possible. So this is 45. This is 45. This is 90. This is 5. This is 5. Well, recall that the hypotenuse is equals to length times root 2 in a 45, 45, 90 right triangle. So my hypotenuse is actually 5 root 2 because my leg is 5. So this part here is 5 root 2. Okay, so it means that this part here is going to be 5 root 2. Now I want you to focus on this triangle here and the one over here. Okay, I'm going to do it again. I'm going to have to zoom it out. Okay, so I'm going to do as close as I can have from there. This is 90. This is the one that we just found, 5 root 2. This was the 60, and this was the 30. Well, to get through this angle here, which I'm going to call it X, all right, because I don't know this part here. I could call it X, or just remember that you don't know this part here, and they are isosceles. Somehow we need to get that. Seems like if I found this diagonal, this hypotenuse here, I will be able to do that. But, well, that means I need to find this side here, right? This should be the long side, right? Because if you're in a 30, 60, 90 degree, we're going to have a short, long side and a hypotenuse. Well, recall that your long side is equal to the short side times root 3. Oh, and look, this one is the short side. So L should be equals to 5 root 2 times root 3. So L should be 5 root 6. And we're talking everything in meters. So just so you know that we're talking about meters, okay? Meters, so you could just put an M there, okay? So the long side is 5 root 6. So I'm going to write it here. I'm going to go back to my original picture. So that's 5 root 6. Okay, well, I'm almost done here. I'm just going to copy this triangle here that I have. This is a 45, 45. 45, 45. And the one that we just found is 5 root 6. How can I find this leg here? Recall that in a 45, 45, 90 degrees, hypotenuse is equal to leg root 2, or the leg is equal to the hypotenuse over root 2. I might be able to do that. So let's find that out. Let's see what can we do to get that particular leg. So h root 2. Let's do that. Let's see. L, which we don't know, is equal to hypotenuse 5 root 6 over root 2. I need to reduce some things here. Okay, so, or you can just, I think we have to rationalize. So let's rationalize this because I cannot have that in the bottom. So times root 2 times root 2. We're going to get 5 root 12 over 2. Oh, but this root 12, so be careful. So I'm going to pretty much do a bubble here. This root 12 is actually root of 2 times 2 times 3, which 1 2 goes out and 1 3 remains inside. Okay, so then this is going to be 5 times 2 root 3 over 2, and this part here, these 2 cancels out. You're just left with 5 root 3. Also, we did all of this transition. We went for this triangle here to this triangle here to this triangle here to find the altitude. We actually found that is 5 root 3 meters. Now we ask, is my cat going to survive? Is the cat going to survive? Well, we don't know. We need to find out if this is actually less than 9 meters. So approximately, either we use a calculator or we use the data given there, that is root 3 is 1.73. You multiply those two. Let's see. Let's see what is 5 times root 3 using your calculator. You get that is equal to 8.66 meters. Oh, and this is less than 9. So that means that our cat will survive from falling from that cliff. So our first answer will be, say, find the exact altitude. By my exact altitude, so I'm gonna write altitude, because they're asking for the exact, they're not asking for the approximate, should be 5 root 3 meters. Be careful with that. They're asking you for the exact altitude. If they wanted you to approximate it, then you will get to give this answer. But they are asking you for the exact answer. Be careful with that. And do not forget your meters. Now, is the cat alive or dead? Well, the cat is alive. So the cat is alive. So the cat is alive. It really survived the whole, when it fell off from the cliff, it survived. So that is for chapter 3, form A. And just make sure you review algebra, your similar triangles. Remember, you must memorize for this test. You have to memorize for sure those 45, 45, 90 special triangle, the 30, 60, 90. You must know them by heart. Make sure you memorize every single time that you're working on a problem, I really want you to be able to, to rewrite a particular problem that you are, the particular formula. For example, here, look, I will show you what we just did here. So remember, whenever we were using this triangle, I wrote, this is my 45, 45, 90. I used this formula, so I'm writing it all the time. And then we did the 30, 60, 90, and I'm writing the formula once again. But here's where the things that I want you to really focus. So we use the 45, 45, 90 again. So I forgot to write that there, 45, 45, 90. However, the fact that I have the hypotenuse here on top, look here on top here, I already have that h equals to L root 2, doesn't mean I will have the freedom of not writing it again. You must rewrite that formula. You want to be able to be writing those formulas until you memorize them. Even though you already memorized them, it's really good. Make that a habit. Every single formula that you're using, write it down, because that will help you a lot whenever you're doing your test. So h equals to L root 2 or L equals to h root 2. So you get to the habit. It doesn't matter if you already wrote it here. The point is that you keep rewriting every single time so you get to memorize this formula. So that will be it for this particular chapter. So make sure you review and study for your test, and I would recommend you to probably redo the test all over again and again. And if the other form, use the other forms, which is form B, and just test yourself, treat it like a real test. So make sure you really understand the concepts behind this. It's not about memorizing what the procedure is. It's really understanding the meaning behind every single problem. So just do your best in your test and do not leave anything in blank.